Welcome back to my YouTube channel. So today we're going to revise different questions involving the actions of alkenes. Let us dive into it. So like the first question, which is question B here, this question was taken from an examination paper. So the question reads, draw the product of the following two reactions showing stereochemistry if necessary. Explain why the product of both reactions are optically inactive. So this question has two areas. The first area which we need to understand is the what? Drawing of the products. And the second part of the question is to explain why these two products are not optimally active. So if you see the first question, this first question, a general overview, we can have an alkene like this. And if we treat with Br2, our product is an addition or adding of a halogen into different position or into opposite side of the molecule. So here, meaning the bromine, one bromine will be added in here, and another bromine will be added opposite. This means that the first bromine which is added here, it is on the wedge, and this one is behind, meaning these are opposites to each other. How does this achieved? Br, meaning here the double bond will be used as a nucleophile attacking this bromine, expelling the double bond. C, the one which has been grabbed, it is this one, Br. Okay, connected to a carbon. So now the behavior here, which results into formation of an addition of a halogen, is that the bromine now has a behavior of closing the upper part. Here, this part is being closed. This will avoid another coming bromine to attack from the front. So this, which is here, another product from after being expelled. So it will come and attack from behind. Let us present this one with this. So it will attack from behind, expelling this bond, meaning our product will be this is the product, meaning the bromine is added into opposite side of the molecule. So this process is known as hydrogenation of alkenes. So this process is referred to as hydrogenation. So let us revise the question here. If you check this process of hydrogenation is as exactly as the first question there. So we expect our answer here to have two hydrogens added into opposite. Two bromine to be added into the opposite position, meaning the first one will be added into here, and the second one will be added into another carbon like that. So this is the answer. But again, the question is saying why this product is optimally inactive. Why do that product is optimally inactive? This is because the product, this one has two chiral centers. This one is a chiral center connected to 4 different groups. If you check here, we have the hydrogen here. So we have group 1, this, another group 2, 3, and 4, the hydrogen. So we have a 1 chiral center here. And then we also have another chiral center from this bromine here. It is also connected to 1, 2, 3, and the hydrogen, different groups. So resulting into having 2 new chiral centers. So these, they cancel each other, resulting into a product not being optimally active because they are mirror images, they're enantiomers. Okay. They are mirror images of each other. So they tend to cancel each other, resulting into the product not being optimally active. Question 2. Question 2 here. Question 2 is the reduction reaction, where the double bond reacts with the hydrogen. Hydrogen is being added to produce an alkane. Overview. If we add hydrogen in PD, meaning this hydrogen will be added into across the double bond into the double bond there, meaning probably our answer will be an alkane. The same scenario is going to be used into this question, meaning here the hydrogen will be just added in here and here, and this double bond will go. So our product will be that's all. Meaning we're done with the question. Now, the second part of the question is explain as to why this second product is not optimally active. So the product formed it's a single asymmetric and does not have any chiral center. Actually, it's an acylo, meaning it is not optimally active because it is a single asymmetric molecule without chiral center. So these have non-chiral centers. Alkenes, meaning that's the answer for this question. Meaning question you are done. Question 2. Question 2 was involving us to write the mechanism, though I didn't copy the part of the question. Question 2 was involving us to write the chemical reaction, I mean the mechanism. But if you check this answer, I mean the product and the starting material, this process is known as hydrazine, or they call it halohydrin. So this process is known as halohydrin. So the mechanism will start first with the starting material, which is then the bromide, so the double bond will be used as a nucleophile attacking that one, the bromine expelling this bond, meaning here our product will be now. Remember that the behavior of the bromine is that it will close the upper part where it is added, where it is initially added. This will prevent water to come into attacking from plant. That's the first step. Second step, we are going to have your water here. This water now will come and attack from behind, expelling this bond. So probably you have the answer with a bromide, which is this one, and the water which has been added, the positive charge. From there now, this water which has been added, it is not stable. It's a good leaving group, so it may leave. That's why we're going to get this, the bromide, the other bromide which was expelled here, Br, to come and get one of the hydrogen, expelling the bond, and finally our product will be which is the same as this one. But the trick part is that the OH is being added into here. There was a mistake, I didn't copy the question, so that was supposed to be this. So the trick part is that the OH is being added to a carbon which has less number of hydrogens. So it follows Markov's law. The bromide will be added to a position where there are a lot of hydrogens, and the OH will be added to a carbon which has less hydrogens. So it follows mechanical addition of OH group into a molecule. That was the second question. B3 leads question A. On treating with HBr, vinyl cyclohexane undergoes addition and the rearrangement to yield 1-bromo-1-ethyl cyclohexane. Using curved alloys, propose a mechanism to account for these results. So here, the first thing that you need to see is the product and the starting material and the product. So let us write this in a skeletal form. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. Yes. So that is the starting material. But here we have not been given the reactant where this will react with the vinyl cyclohexane will react with what we have not been given here. But what we have been given is the answer. With a bromide added here. So if you check this answer and the starting material, meaning we are just adding the hydrogen here and there is the arrangement of an ion, meaning the positive charge which was supposed to be here has been transferred to that one, to this carbon here, which is in tertiary carbon, where the bromine now is being added. So meaning here this one was undergoing hydrohalogenation. So we will expect to have hydrogen bromide here. Let us now write the reaction mechanism. So here we have HBr. This will come and attack hydrogen, expelling this bond. Meaning you have your answer. Your hydrogen will be added to a position where there are more hydrogen, Markov's law. The positive will remain here. But if you check, this is the secondary carbon. So we are saying secondary carbon is less stable than tertiary. So expect rearrangement here where there will be a hydride shift. The hydrogen which is here is going to move into that position, and this positive charge will move into that position. So meaning we'll have a carbocat ion rearrangement. The hydrogen denote it by the red color here. Then here there's a positive. And what has happened, this is what we call hydride shift. And finally now you have your BR. This now will come and attach itself where there is a positive charge, resulting into the final product. Meaning this is the end of the problem. If you check now, this is as exactly as this product, 1 bromo 1 ethyl cyclohexane, meaning the problem has been solved. Diving into the last example that we have, last questions. So question 2 here, this alkene is subjected to hydrochloric acid. So this to undergo the process known as halogen. The alkene will undergo the process known as hydrohalogenation. Hydrohalogenation, where the hydrogen and the halogen will be added to the alkene. So the process is what we call hydrohalogenation. But it will follow Markov's law, where now this hydrogen will be added to an area where there are more hydrogen, and the chlorine will be added to a position into a position where there are less hydrogens. So it will undergo Markov's law. So the product that we expect here is here we have our CH3 with our chlorine, and the hydrogen will be here. That's the answer. So the process has followed anti-Markov's law. Question B, also the same thing. The hydrogen will be added where there is less number of hydrogen into this double bond. Here there is less number of hydrogen, more number of hydrogen. Then the bromine will be added to a position where there will be less number of hydrogens. So probably here your answer, your answer is going to be the hydrogen will come here, the bromine will be in this position. That's the answer. Okay, number 3. In this case it was number 4. Now this one, we are subjecting an alkene into an acid. So whenever you are subjecting an alkene to an acid, the product will be that the hydrogen will be added to a less substrate, and there will be rearrangement, form a stable carbocation ion. And the reaction is known as acid catalyzed hydration reaction. So here, allow me to use the other part of the body. So here, this is the acid. That bond will come and get the hydrogen, explaining that bond. Meaning here will follow Mechanical law, where the hydrogen will be added to where there are more hydrogens, and the positive charge will be here. From here now, there will be rearrangement, where now the molecule will attain its stability. The anion will try to be stable because here it is on secondary, and here there's a tertiary. We have a hydrogen here. So meaning this hydrogen will move into this position, secondary position, and the charge will also move to that position. Meaning here will result into our molecule having a positive charge here. Finally, from there now, the OH, the water which has been expelled from this part here, it is the same one which is here. This now come and get added there. Now the product now here, from here it will be with a positive charge, 1 pair. From here now, after finding this answer, we are going to use another water molecule to get rid of one of the hydrogen. So this is another water molecule which is going to get an hydrogen, explaining this bond here. So here you have your final answer, as you know, OH being added to a more substrate carbon. So this is your final answer, plus H3O plus as a catalyst. So here our product is okay. We are remaining with 2 questions. Question 5 and B. Question 5 also, it follows Markov's addition, meaning the OH will be added here. We're going to talk about this mechanism into our next class, but for now just know that the OH from water is being added into the position where there are less number of hydrogens. So our answer here will be okay. The same applies to this process of the question B, which is the process of oxidative cleavage. Some they say oxidation process. This is out into formation of 2 products. The oxygen here, which is here, is capable of breaking this bond. After breaking, we are going to have two products. The first product will be that's where the bond has been broken, the position where the bond has been, just like this. So you just add oxygen from here, and you just add oxygen here, hydrogen there, and hydrogen here. But if you have a terminal alkene, meaning you are going to form two different products, an aldehyde and the ketone. But in this case, we are going to have two aldehydes because it is an internal alkene. We are going to explain this process and the oxidative cleavage and the other one in our next video. So for you to access a lot of videos on my platform, please subscribe to my YouTube channel for more videos. If you have a question, please drop the question in my inbox, or you can just comment. All right, thank you. Shalom, shalom.